scientific for this one.
Okay.
All right, so type in the 9 minus 5. And I mentioned this to you. Yeah, go to minus 5. I mentioned this to you before. If you type times pi, so times and the pi symbol, and then divided by 180. So do a slash 180 divided by 180 somewhere. Notice it gives you a decimal, okay? And that's not what it's. Oh, this one. Oh, I'm sorry. I take that back. This is going the other way. So we actually need to flip the 180 in the pi in the calculator there. So 180 on the top and pi on the bottom.
Cool.
And then you just round to one decimal place. So minus 286 point, and see that 4 will go up to a 5 because the 7 causes it to round up.
Okay. This is the one that I was kind of stuck on.
Okay. Yeah. So go ahead and go to your calculator over there on the right and type in 5 pi over 6, just like it's got there. And then you want to multiply by 180 over pi. So what this is doing is it's converting it 2 degrees. And you'll see that it's 150 degrees, okay? So the angle starts on the x-axis, okay? Can you put your cursor on the top left angle there? On the x-axis though, to the right a little bit, where it's more right, right there, right where it's starting. Now, if you follow that curve up to the left until you hit the y-axis, could you follow with your cursor up to the along the curve that, yeah, right there, that's 90 degrees. It's rotated 90 degrees there. Okay, does that sync up? Like, is that a clear? So
yeah,
150 is obviously more than 90. Now, if you keep going left further around to the x-axis, if you keep moving left along that circle, I don't see your cursor moving, but you guys can see, if you keep going all the way down, keep going a little more down, a little more, keep going down, all the way to the x-axis. There, right there. So if you were to go all the way down, a half circle is 180. So 150 is somewhere between 90 and 180. So that's your answer for that one. Okay, so 240 degrees, kind of the same deal. Okay. We have to figure out, well, where are we going? Now, one of the answers, go ahead and look at that answer on the right, top right there. Do you see how the circle is going in the wrong direction? It's going clockwise instead of counterclockwise.
Yeah.
Okay, so it's, oh, you know what? This is negative. Isn't that a negative measure of negative 240?
That would be, I think, but it's just positive 240.
But look at it says select the angle with a measure of dash minus 240. What I'm referring to is up where the question is. Could you make
yeah, it has a dash right here. Yeah.
Is it negative or not?
Yeah, it's negative.
Okay, so negatives go in the clockwise direction. So that means it's either the top right or the bottom right, because you can see the 2 on the left, they go in the other direction, they go counterclockwise. Do you follow that?
Yeah.
Like the old clocks. So it's between the top and the bottom one. Now go to the curve in the top right. And if you were to trace along the red, trace until it's 90 degrees, right? There's 90. Then you keep going. Yep. That's 180 right there. And so a little bit more gets you to the 240. So what you have to first decide here is, am I going clockwise or counterclockwise, depending on the direction. So negative angles, I'm just writing this down. they go clockwise. And it's a totally legitimate term in this class. And then positive angles, they go counterclockwise. They go the other direction. You can go ahead and submit that one, and we'll look at the next one and see what it says.
You said negative angles go counterclockwise?
No, positive angles go counterclockwise. Negative angles go clockwise. And I'm writing this down. I'll send this notes to you, but that is, go back to the previous problem because you'll see this really quickly. The one we selected went to the left. It started and moved left. That's counterclockwise, and that's positive, which seems not intuitive, but that's what it is. Okay, so let's go to a new problem. And what I'm trying to do is show you how to remove a couple of possibilities right away.
Right. Okay. Oh, this is the last one.
Say that again.
I said, oh, this is the last one on this problem section.
Okay, great. Let me, I'll have to snip this in and we'll work on it together. So let me get that snip going. All right, I will share my screen. All right, find the length of the safety rail and the area of the deck. Okay, so the safety rail is along here, and it may not appear obvious, but it's a quarter circle. And from a previous class, you know that the circumference of a circle is 2 pi r. 2 pi times radius, but that's if you want to go all the way around the circle. Here we only want to go around a quarter of it. So the circumference of a quarter circle is 2 pi r divided by 4. Pi is not a variable. Pi is straight pi. The r is your radius. Your radius is 10. So in this problem, you just substitute your radius and use that Desmos calculator and go ahead and calculate it. It says to round to the nearest 10th, so 1 decimal place. And that whatever you get there will be our answer for this box, first box.
Don't close the door. That's my shoes. 15.70.
Just 1 decimal place though, so maybe 15.7.
Yeah. And I love you. All right. So then the area of the deck now.
So the area is pi r squared, but you want the area of a quarter circle. So that's pi r squared divided by 4 because you want a quarter of it. Your r is 10. Okay, so you can enter this again into that Desmos, round to 1 decimal place, 10th, 1 decimal place. So it'd be 15.7 if that's what you got there.
Yeah, this one I have 78.5.
Okay, go ahead and try it.
Yeah, cool.
All right, so whenever you're ready, go ahead and share whatever you want us to look at next.
Okay.
All right, so I'm looking at this, and could you go ahead and make this full screen? And I want to just have you go through each problem. I want to see what the types are. Okay, keep going. Okay. Let's do this. Go ahead. I was going to suggest we do some of those, but some of those will not be very nice. Okay. All right, let's go back to number 1. We'll just start there.
Okay.
All right, so we got to find all 6 trigonometric functions. I'll share my screen here. All right, so there's a triangle that's associated with every quadrant, and I call it the reference bow tie, because the triangles that are the reference triangle in each quadrant, they look like a bow tie here when you're all done. Okay. Now you are in quadrant 4. This is quadrant 4. 1, 2, 3, and 4. And I didn't come up with this. This is just the way nature of it. It does kind of follow with the whole like unit circle going left. Sorry, I was meant to grab another color there. With the unit circle going left, you can see that that's why it's goes that direction. But nevertheless here, so why did I draw this thing on the right here? It's because you have to figure out, which quadrant you're in, potentially, and this can help here. So what you got here is a triangle in this quadrant, in this 4th quadrant, okay, where 5 is the x and minus 12 is the y. 5 is the x and minus 12 is the y. So it's, I don't know if you can see it, but it's this triangle right here. We need to find the 3rd side, and this is a Pythagorean triple. Pythagorean triples are the ones that we like because they follow nicely. They're integers. Okay. And the hypotenuse is always positive in these situations. Okay. So now that we have the 3 sides of the triangle, here's the angle. Okay, we can find the 6 trig functions. So what's the first one they give you? Is it sine in the top left?
Yeah.
Okay, so sine of theta equals opposite over hypotenuse, minus 12 over 13. I think cosecant theta is to the right of it. It's the flip of this. So you would do 13 over minus 12, but generally the negatives are in the top.
Okay.
Cosine theta is the adjacent over the hypotenuse. Secant theta is the reciprocal of that. So it's going to be 13 over 5. And then we're down to tangent of theta. Tangent of theta is opposite. And we're looking at this angle right here, opposite over adjacent, so minus 12 over 5. And then the cotangent is the flip of that, minus 5 over 12. So once you have all 3 sides of your triangle, you can very quickly determine the sine, cosine, and tangent.
Okay. And then also, I'm going to get my computer charger, so I will be right back.
Sounds good. let me know when you get back.
Hello, I'm back. Hello? Hello?
Hey, Jayla, are you back? Looks like you're back.
Yes.
Okay. It was really unclear what what was going on, so
My
I just stepped
computer.
away. All right, great. So if you're seeing my screen, very similar to the last problem here, we draw the triangle that is the reference triangle for that side, and the first number is the x, second number is the y. Okay, and then we immediately find the hypotenuse. Now, this is another Pythagorean triple. It's a 3, 4, 5, but you can always multiply these by 2. So that's 6, 8, 10, and that tells you that this hypotenuse is 10. Okay, so the angle is right here. It's always, maybe I didn't put that in the previous picture, but the angle, it always converts to one of these, the one that's closest to the x-axis. So in this case, your sine of theta is opposite over hypotenuse. It's -8 over 10, but you have to reduce that to -4/5. Okay, the cosecant of theta is the flip of that. Okay, and then the cosine of theta is the adjacent over the hypotenuse, and then you reduce. Secant is the flip of that, -5/3. Tangent is opposite over adjacent, so -8 over 6, -6, and that becomes +4/3, and then cotangent is the reciprocal of that. So go ahead and just enter those and go ahead and share your screen over your ready. I just need to step over for 30 seconds. I was grabbing something and then I saw you got back online. So just give me just a moment, but we'll work through the next question here shortly.
Okay.
All right, so this problem is going to require a bit more work here. Let me snip it. This is the first non-Pythagorean triple, so it's not as nice, so to speak.
Okay.
All right, so let me share my screen. Okay, so again, we're in the first quadrant. And so the reference triangle we draw here, 3 is the x, 1 is the y. And you have to find the hypotenuse. Now, because it's not a triple, you can't just like write the number. You have to go back to good old Pythagorean theorem here. So your a and b are the legs, the short ones. 1 squared plus 3 squared equals c squared. 1 plus 9 equals c squared. 10 equals c squared, so c equals the square root of 10. This is all review on the right. You know how to do that. Make sure you're comfortable with it, but you can absolutely do that. So now sine theta is opposite over hypotenuse. So it's 1 divided by the square root of 10. If what I remember, your software would allow this form. Like, you're supposed to rationalize, and we saw that on the quiz review, but should accept this. Cosecant, and this is where, you got to remember, you only have to do this one because cosecant is the reciprocal of it. Cosine of theta is the adjacent over the hypotenuse, 3 over the square root of 10. Secant theta is the reciprocal of that, the flip. Tangent of theta is going to be opposite over adjacent. It's going to be 1 over 3, opposite over adjacent. And then cotangent is the reciprocal of that, 3 over 1.
Okay.
Okay. This one actually is a Pythagorean triple, but maybe isn't obvious to start. Let me grab a snip of it and we'll look at it together. So I hope you can at least, I mean, I don't expect you to say, oh, this is really interesting, Matthew, or, hey, I love this, but do you see that these are all the same in terms of the process?
Yeah.
You draw the triangle, you find the third side, and then you write the three trig functions. So this one is -12, -9. And there's a 3, 4, 5 is your triple. And so why do I know that this works? Well, if you multiply each of these by -3, you get -9, -12, and -15. But again, I mentioned the hypotenuse is always positive, so you don't use the negative of that. But the A and B here, they're the -9 and -12. Your angle here is theta. So sine theta is opposite over hypotenuse, -9 over 15, but that reduces to -3 over 5. And then cosecant theta is -5 over 3. It's the flip of this, but with the negative on the top. Cosine of theta, if you go back to your picture, it's the adjacent over the hypotenuse, -12 over 15. And that reduces to -4/5. Secant theta is the reciprocal of that, that's -5 over 4. And then tangent of theta is opposite over adjacent, so -9 over -12, which they both divide by 3, or -3 in this case, so 3/4. And then cotangent theta is the flip of that, which is 4/3.
Okay. Okay.
Okay, yeah, so this one's kind of like number 3, where we're gonna have a little more work to determine the missing side, and then we'll have some roots in our answers. So let me share my screen.
Okay.
All right, so again, we're in that 4th quadrant, so the triangle looks like this. The x value is 1, the y value is -2. A squared plus b squared equals c squared. We have 1 squared plus -2 squared equals c squared. 1 plus 4 equals c squared. And then you take the square root of both sides. C is the square root of 5. So this is our hypotenuse. It's always positive. And then theta is here. Theta is always the one that's made with the x-axis. I know they say theta is here, but you can readjust it here. Obviously, it's been working. I mean, you haven't said, "Hey, Matthew, these aren't right. These are these are all working." So it is always that angle made with the x-axis. And I'm not trying to tell you these things to like because they're interesting or exciting. I'm trying to tell you like what is always true. It's always the angle with the x-axis. That way, when you get to the quiz or the test, maybe you'll remember it's always the angle with the x-axis. So the sine of theta is the opposite over the hypotenuse, -2 over the square root of 5. The flip of that cosecant theta is the negative square root of 5 over 2. Cosine theta is the adjacent over the hypotenuse. And then the secant of theta is the reciprocal of that, the square root of 5 divided by 1. Tangent of theta is the opposite over the adjacent. It's -2 over 1, or just -2. The cotangent of theta is the reciprocal of that. It's -1, 1/2. All right, so yet another one. You're probably seeing the pattern here. The again, the angle really doesn't matter actually, even though it probably appears like it's a different problem. So let me snip that in, and we'll take a look at it. After I grab a snip of this, which I've done, could you tell me if we've got any more of these problems, or if they're, because we may want to move to something else.
Yeah, the rest like
okay. Yeah, and so I'll talk you through some of those. Some actually can be done with the calculator, so we'll do the ones that we can do. But let me share my screen and get started here. So again, I'm going to just draw that reference triangle that I keep mentioning here. There's theta. X is 4, y is -3. And this is a 3, 4, 5 triangle, so the hypotenuse is 5. It's always positive. The sine of theta is the opposite over the hypotenuse, -3/5. The cosecant of theta is the reciprocal of this number, -5/3. The cosine of theta is 4/5. And so the secant of theta is the reciprocal 5/4. Then there's the tangent of theta, which is opposite over adjacent, -3/4. Cotangent theta is reciprocal of that, -4/3. You know, it all starts with SOHCAHTOA.
Okay.
Okay, so I want you to make this the left side of the screen, and then on the right side, pull up your Desmos calculator.
Mhm.
And I want you to type in sine and then 7 pi over 2.
Okay. 0.
Your 7 pi over 2, the divided by 2 has to be inside the parentheses. So I would delete everything and start over again on that to make it easier.
Like this?
Yes, that is what it's looking for. So when you look at that, and you need to be in radian, whenever you see it in pi, it's got to be in radian. You're in degree right now.
Mhm.
Your calculator has to be in radian, not degree. Okay, so see how it gives you a nice number there?
Mm.
So that's the answer. The answer to sine is -1.
And then would it be 1 for the other one?
Well, no. You flip it. Flipping it doesn't negate it.
Oh, okay.
Flipping it in this case, it's going to be the same number. -1 divided by 1 is -1. Okay. Now go to type in cosine 7 pi over 2 instead of sine. That's 0. Okay, now the reciprocal of 0 is not 0. You can't put the same one in. It's not always the same. 0. Think of 0 as 0 divided by 5. You have nothing to share with 5 friends. Okay, that's what 0 divided by 5 is. If you flip it, 5 divided by 0, okay, that means you have 5 things to share, but nobody to share them with. Okay, and we call that an undefined situation. Whenever 0 is on the bottom, which is the flip of 0, then, okay. So go to tangent of theta, type in tangent of 7 pi over 2.
It's undefined.
Yes, so then the reciprocal of that is generally 0.
Cool.
Okay, so do the same thing. Type in sine of -270, but this time you're going to have to do it in degrees. Okay, you got to get rid of the pi, got to get rid of the divided by 2. Okay.
1. Okay.
Okay, now the reciprocal of 1 is 1. The reciprocal of 1 is 1. Like 1 divided by 1, you flip it, still 1 divided by 1.
Okay.
So 1 and -1 are the only reciprocals that equal themselves.
Okay.
So cosine is 0. When you flip 0,
undefined.
yes.
Undefined. 0.
Okay, so this one is it's whenever you see a pi, and I'm sorry, whenever you see no degree symbol, and often when you see a pi, you change it to radians. So yeah, it's going to be -2 pi. but make sure you put your mode correct. Yep. Okay, and that's 0. Very good. Okay, so you can do the same thing here for this one.
Okay. Okay. And that was actually all of them.
Fantastic. Well, thank you so much for scheduling. I'm glad we got through everything, and I guess I'll see you next time.
All right, will do. Thank you so
Have
much.
a great day. Bye now.